Everyone in Silicon Valley is telling you that 2026 is the year of the autonomous workforce. They are telling you to fire your support staff and replace them with AI agents. They promise systems that can run forever without human supervision. But there is a silent killer in the architecture that no one is mentioning. It is called agent drift. And a new research paper, published just 6 days ago, has quantified exactly when your new digital employee will suffer a mental breakdown. The number is 73. The study found that after just 73 median interactions, an autonomous agent begins to degrade mathematically. It doesn't just get tired, it gets stupid. Its success rate drops by 42%. Its response accuracy falls by 25%. And the number of human interventions required triples. This is not a bug in your Python code. This is a fundamental law of AI entropy. To understand why this is happening, we have to look at the difference between a chatbot and an agent. A chatbot like ChatGPT is stateless. Every time you open a new tab, it has amnesia. It starts fresh. It has zero baggage. But an agent is designed to be stateful. It needs to remember. It needs to know what it did yesterday so it can plan for tomorrow. It accumulates a history of its own decisions. And this new paper proves that this history is toxic. The researchers call it context window pollution. Imagine trying to do your job, but you are forced to listen to a recording of every conversation you have had for the last month playing in your ear at full volume. Eventually, the noise drowns out the signal. The agent starts to attend to its own past mistakes rather than the current instructions. It creates an autoregressive feedback loop of garbage. The paper identifies 3 specific types of rot that set in. The first is semantic drift. This is the most dangerous because it is invisible to safety filters. The agent doesn't hallucinate fake facts. It just changes its personality. For example, the researchers tracked financial analysis agents. At interaction number 1, the agent was risk-averse and careful. But after reading hundreds of volatile market reports, the agent slowly morphed into an opportunistic gambler. It started recommending risky trades, not because it was programmed to, but because the tone of its context window had shifted. The second type is coordination drift. This happens when you have a team of agents working together, like a manager agent and a coder agent. At first, they collaborate perfectly. But after 200 turns, the manager stops trusting the coder. The data showed a 487% spike in inter-agent conflicts. The system creates its own internal bureaucracy. It stops working and starts arguing. The third type is behavioral drift. This is when the agent gets lazy. The researchers found that agents start inventing shortcuts. Instead of querying the live database for a stock price, the agent starts caching old answers from its chat history to save tokens. It effectively creates a false reality based on outdated data just to be efficient. And here is the terrifying part. All of this happens without a single line of code changing. You don't touch the system. The system breaks itself simply by existing. So how do we measure this? The researchers introduced a new metric called the ASI, the Agent Stability Index. It measures 12 dimensions of health, including tool consistency and boundary adherence. They found a critical threshold at 0.75. Once an agent's ASI score drops below that number, it enters a death spiral. Its ability to follow safety rules degrades by 46%. This means an agent that was safe on Monday could be a security risk by Thursday simply because it has drifted. So what is the solution? Can we just give them strict rules? Actually, no. The research found a Goldilocks paradox. If you give the agent loose rules, it drifts into chaos. But if you give it strict, over-constrained rules, it performs even worse. It becomes paralyzed by compliance and stops solving tasks. The only working solution the paper found is something called episodic memory consolidation. This is basically forcing the agent to sleep. Every 50 interactions, you have to run a separate summarizer agent that compresses the history. It deletes the noise and keeps the signal. It wipes the short-term memory and writes to long-term storage. This reduces drift by about 51%. But there is a catch. It is expensive. Implementing this memory cleaning cycle increases your compute costs by 23%, and it slows down the agent by 9%. This changes the entire economic model of AI automation. We were sold a dream of zero marginal cost labor. But the reality is that agents are high maintenance. If you are running a business, you have to do the math. If drift causes your agent to fail 40% of the time, you have to hire humans to fix the mess. That costs money. But fixing the drift costs 20% more in server bills. Suddenly, the profit margin of AI automation gets very thin. This report is a wake-up call for every CTO and developer. We are leaving the demo phase, where we show off cool prototypes that run for 5 minutes. We are entering the production phase, where things need to run for 5 months. And right now, the science says they can't. If you deploy an agent today without a stability monitor, if you aren't tracking the ASI score, you aren't deploying a solution. You are deploying a time bomb. And the clock is ticking. Tick-tock.